So hopefully you've already seen the first video. We are talking about intervals of increasing and decreasing, estimating, describing extrema. This is part B, so we're looking at this second graph here. This is a polynomial. As we're looking at this polynomial, we're going to read it from the left to the right. We're going to find out over what x value intervals it was going up, at what x value intervals it's going down, what x value intervals it's going up again, going down, and then we're just going to see what happens. So as we go from the left to the right here, going from the left means we're starting at a negative infinity. Starting at negative infinity over here, as I move to the right, the graph is going up. So I have to move to the right, and I can see it's going up, and it continues to go up until I get right here at this x value of a negative 3. So the first thing is I know it increases for the x values of negative infinity to negative 3, and I'm putting that in interval notation. We can't equal negative infinity. It's not actually increasing at this point, but it stops increasing right there at the point. So then we continue on. I can see as I continue to the right, it's going down, it's decreasing until I get right here at this x value of 1. So it decreases until I get to the x value of 1. So from negative 3 to 1, it was decreasing. Again, at both of these points, it doesn't actually decrease at the point, so we just put parentheses. As we continue to this x value of 2, 3, 4, it was increasing in that area right there. So then it increases from 1 to 4. Right here, it decreases until it gets to the x value of 5. So from 4 to 5, that would be an interval of decreasing. And then right here from this 5 onward, it increases again as we continue to the right, as we continue to a positive infinity. From 5 to positive infinity, it continues to increase. So we can put all these together if we wanted to. Interval of decreasing, we could say this is negative infinity, or sorry, this is our interval of increasing from negative infinity to negative 3, union with 1 to 4, union with 5 to infinity. This is all of our intervals of increasing. Our intervals of decreasing from negative 3 to 1, you can union that with 4 to 5 just to list those all out together. Now extrema, again, is a fancy word for turning points. And turning points is when it has changed direction. We just use those points to find when it's changing direction from increasing to decreasing or vice versa. So it's these 1, 2, 3, 4 points that we care about. Those are the extrema. This point right here is negative 3, 10. This point right here is 1, 1, 2, 3, 4, 1, 4. This point here is 4, 7. And this one is 5, 6. So for extrema, we can have minimums and maximums, and those minimums and maximums can be relative or absolute. You can check the previous video to see an example of an absolute extrema, but in this case, none of these are absolutely the highest point or the lowest point. Though this one seems really tall, like that is the biggest and most vertical point we see on this entire graph, but notice this arrow is pointing up, so it's going to eventually get a lot more, we're going to get to a lot greater y values than what we see right here. So this is not an absolute maximum, this is a relative maximum. So we're going to have some relative max, and we can have some relative mins. So minimums and maximums. So in this area right here, that is the highest point, but it's not the highest point on the entire graph because we know it's going to get higher. So a relative maximum we have is negative 310. There's nothing around it that's higher than that point. So relatively, locally, that is the highest point. It's a maximum. Down here, in this area, this change direction at a low point, that is a relative minimum at 1, 4. As we continue over here at 4, 7, in this location right here, this is the highest point in that area. So we have a relative maximum at 4, 7. And then finally, we have another relative minimum at 5, 6. So in this case, we had no absolute because though this is a low point, we can see that it gets lower. And though this is a high point, we have several high points, they get higher. So they have to be the absolute highest or lowest point of the entire graph to be absolute. These were just relatively the highest points in their vicinity.